Hi, I'm going to show you how to use Mojo, a new programming language from Modular, which is quite interesting because it's a lot like Python, but it has the potential to be much, much faster and also to integrate better with GPUs and other accelerators for AI applications. I'm really interested in any language that makes Python faster. For example, Python, which lets you write C extensions to Python and has its own language. I made up the name Python and I got that project really going in the early days. But let's dive into Mojo. So here we are signed into CoCalc. I'm going to click on my projects and I have a demo project already set up, but open whatever project you want. And now let's create a compute server by clicking on servers and then compute server. I'm going to name the compute server. It doesn't matter at all what you name it, but I'm going to go to the Mojo modular website so that I can copy and paste the little fire emoji. And I'll call it Mojo. And then also let's change the color to be a nice bright orange. Excellent. Okay, otherwise the Python image is just fine. Mojo does a lot of just-in-time compilation, so it's really important that we have a fast CPU. So at least I'll try a C3D standard. And I think that's everything we need to do. So let's just start this thing running. Okay, it's now starting up. In the meantime, we need to figure out how to install Mojo. So we'll just end up copying this into a terminal in a moment, but you'll have to sign in, and I'm already signed in, and that it's kind of necessary to really get going with installing Mojo itself. So it says install Mojo guide, and here we are. This looks like a great guide. The compute server we just created on CoCalc is running Linux. So let's switch to Linux, and we're just going to follow these directions. So let's see how we're going over here. Our compute server is booting up. It's almost done. Synchronizing the file system. Now let's go over here and make a terminal, which I'll just call Mojo. Click on Linux terminal. And then I don't want it to run on the shared resources. I want it to run on my new Mojo compute server. So let's do that. Okay, my terminal is now running on Mojo, and now I'm going to install, following the directions, Mojo. So first let's copy and paste from here. So it's doing the installation. And then once it's done, it's going to run modular auth, and that will require me to paste in a secret token. Oh, let's see, what does it say? To get started, blah, 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 verify using this code. So here's my code. Looks like I have to click on this link. Then we have a little code actually filled it in. So I click continue. I'm going to improve CoCalc, and we're almost there. And let's see, we just want to finish doing the installation. So we did step 2, and now we want to install Mojo itself. What we just did was we installed a package manager from Modular, and now we're going to install Mojo, which is the compiler. And, well, in general, the standard development kit. Okay, so it's doing the installation. Let's let it finish. And once it's installed, there should be a Jupyter kernel, and we can test that out. And we can also use VS Code and install the extension there. But let's wait for the installation to complete. By the way, if we click split screen, and then set this other terminal to run, we can use top and see just that at least something is happening on the server. And indeed, look, there's a huge amount of CPU being used. And there we are. Mojo is now installed. Okay, so what does it say over here? It says we should take, in order to get Mojo, we should copy and paste what's here. So CoCalc uses bash by default. So let's copy and paste this into our bash RSD. Boom. Okay, we've done that. And now let's type Mojo, start the Mojo REPL, and see if it works. And yes, we computed 2 plus 3. Woohoo! Okay, also let's type Jupyter kernel spec list. That's how you can see what Jupyter kernels are available. And there's a Mojo kernel. Woohoo! All right, so let's click new and then click, let's say Mojo, and then we're going to make a Jupyter notebook. And by default, it just runs in CoCalc's big, massive shared environment. But where it says server, if you then select Mojo, it will run on our Mojo compute server, and we have the Mojo kernel available. Okay, here we are. So print 2 plus 3, and that will compile it and run it. Notice kernel is starting, kernel's running, and hopefully it will just in time compile to print 2 plus 3, and then we'll see our output. And boom, it worked. And maybe, let's see, let's try something a little more complicated. Def do math var y equals x plus x, y equals y times y, let z equal y plus x, print z. Oops. So this illustrates the var and let commands, and apparently let is being removed. Okay, Mojo is under active development. So I'll change that to var do math 10 and 410. Great. So we have Mojo working in a Jupyter notebook. One thing I like to check every once in a while is to see whether generative AI knows anything about Mojo. So let's try this Claude 3 Opus model. Write a Mojo program to compute the sum of the integers up to 100. Let's see if it can do anything at all. Last time I tried this a couple of months ago, the AI didn't know anything about Mojo at all. But here it seems to be trying to do something. Let's see what happens. Nope, 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 totally doesn't work at all. All right, well, you're not going to be using Mojo with generative AI unless you use some other approach where the model is specifically trained. Like, there's a lot of issues here. Okay, I did try writing a little program in Mojo. Let's try it out. So gcd.mojo. If you end your file with Mojo, you get syntax highlighting and nice little Mojo mode. Now let's try running this code. So we'll split the, let's see, it'd be better if this was on the Mojo server. Okay, now it's on the server, and let's go over to our terminal. Make sure it's there. And now let's do Mojo build gcd.mojo. Okay, and apparently, again, I was using let, but let's change our lets to vars, because apparently when I wrote this last, let was a thing and now it isn't. So try again. Oops, I have to sync. Excellent. So you now have a binary called GCD. And let's give it a shot. And there it is. It computed a GCD. Excellent. Another cool thing you can do is use Python from Mojo. Let me show you how to do that inside of this Jupyter notebook. So right here, there's a module called Python, and we can import it. Let's see, again, there's issues with let. So we'll use var. And now we're calling Python from Mojo, which is pretty cool. All right, so that's using Mojo from or within CoCalc. Again, the summary is that you simply follow the standard directions to install Mojo, exactly like on the Mojo website. Just make sure you say that you're installing it on Linux, which is what you get with CoCalc, and it just completely works. You copy and paste things for the bash terminal, and you then have Mojo up and running, and you can use it on CoCalc with whatever compute server you want, and it's nice and snappy, but it's Mojo, so you have to put print, and there you are. When you're done, you can go to your compute server, and if you're completely done with it, just deprovision it. If you're going to come back to it, you may want to just stop it. And when you hover over it, it tells you that stopping it will cost up to $1.30 a month. And if you deprovision it, that just completely deletes everything that's on the compute server. And that's what I'm going to do. Okay, thanks a lot. I hope you test out using Mojo on CoCalc.